Okay, so hello. Thank you for coming to my talk, the almost complete Ldap guide. So the reason I chose the word guide for the title of this talk is because I truly believe you will be able to use these slides as a guide in order to know Ldap better or improve your Ldap detection or maybe discover a new enumeration technique. So I really hope you'll find it useful. So about me, my name is Sapir. I work at CrowdStrike in the identity protection group as a security researcher. Basically, I love everything related to identity. In the past couple of years, I had the chance to research Azure Entra ID, AWS Identity Center, Okta, and Active Directory. So today we are going to speak about Ldap. So what's Ldap? It's the lightweight directory access protocol. So when we say directory, in this talk, we will only talk about Active Directory. So Ldap can be implemented for different types of directories, but this is obviously the AD track, so we are going to speak about Active Directory. So we all know that AD object has attributes, and we use Ldap to query these attributes or modify these attributes to get more information. So some of you may ask yourself, do people still use Ldap? So let me just delegate permissions to Twitter to answer on my behalf. People most definitely still use Ldap. So even though Ldap is old, and also a lot of people already talked about it, I really hope that each and every one of you will learn something new from this talk, maybe except a few people here that I probably can't teach you anything. So what are we going to speak about today? We'll start by talking about the usage, so who uses Ldap and why. Then we'll speak a bit about the traffic flow, so the initialization function, connect, bind. And these are quite important, since we'll use them to understand what encrypted Ldap session means and how we can decrypt GSS API encrypted traffic. Then we speak about Active Directory web services. And later we talk about some attack tools and enumeration techniques and how we can detect those. And finally, we speak about how we can use Ldap for defense and what we can do with ETW when it comes to Ldap detections. So usage. Most of you probably think, OK, Ldap, we know Bloodhound, AD Explorer, a lot of attack tools and techniques to enumerate Active Directory environment. That's obviously correct. But also some IT administrators use Ldap just to get information about their environment and maybe create users and stuff like that. And there is also another party that uses Ldap, and that's Windows. So Windows by default uses Ldap, and this is quite important, since if you want to create good Ldap detection and avoid false positives, you should be aware of the golden image of your environment, what's the default behavior in your environment. So I gave you two examples. So the first one is GPO. You can see the GP link and GP options attributes. So some of you may think this is the GPO enumeration query. And indeed, some of the GPO enumeration queries looks the same, but this is also the output of the GP update command, which is default Windows behavior. And actually here, so some spoiler, the way to differentiate between the default behavior and maybe attacker's behavior can be, for example, using the time limit, which here it's 240. So this will always be for GP update. So this might be a nice way to differ between these two scenarios. And also, we can see the GMSA, so the Group Managed Service Accounts. So each time a machine wants a service to run on a GMSA account permissions, it needs to retrieve the password from the MSDS Managed Password attribute. So this might look like an attacker tries to read the MSDS Managed Password attribute, but this can also be just how GMSA works. So the previous slides kind of lead me to this one, which is the plan. So the plan is to know Ldap the best we can, and then it would be easier for us to detect Ldap anomalies better. Or maybe I should even say that the plan is to know Ldap better than the attacker does. And then it will be easier for us to catch it in the places that it even doesn't aware that it look anomalous. So some basic concepts. So when we speak about Ldap search query, we have some parameters that we should probably know. So the first one is the base object. This is basically the folder that we are going to search in. And we can control the depth of the search using the scope parameter. So for example, the whole subtree. Okay? The whole subtree will search the folder and all of its subordinates, but we can also search only the folder or maybe the child folder, and this will have a great effect on the amount of results we are going to get. Then we have the dereferences parameter. So this one is quite interesting. So from what I've managed to understand, actually Active Directory doesn't support this feature. So this value should always be 0. So it might be quite interesting to check if you have in the environment some Ldap traffic with non-zero value here. Maybe its attacker tries to color its packet or something like that, and it doesn't aware that it looks very anomalous. And then we have the size and the time limit. So the size limit limits the size, and the time limit creates a timeout for the query. And this can actually be quite useful, as I already spoke about it in the GPO example, to differ default behavior and attacker's behavior, maybe even sign specific attack tools. Then we have the filter, which we will talk about in a couple of more slides, and the attributes. So the attributes, basically, it's what information we want to retrieve on the object that fits our filter. And this is quite important as well, since every attack tools look or ask for a different set of attributes, so we can use them to sign the specific tool. Now, let's talk a bit about the flow. So first, we need to initialize a connection towards the Ldap server, which is our domain controller. So we have two functions we can use. The first one is Ldap init, and the second is Ldap SSL init. So this slide is quite important. So we all know Ldap default port as 389. This is the port, the default port for the Ldap init function. And we know that Ldap S is mostly seen at port 636. So this is the Ldap SSL init default port. And we also have the global catalog ports, which are 3268 and 3269. So first of all, if you monitor Ldap traffic in your environment and you use it using the 389 port, you should probably be aware of the fact that there are 3 more ports that has Ldap traffic as well. And if you think that Ldap with port 389 will always be unencrypted, this is actually a mistake. Ldap with port 389 might be encrypted, and even most of the time encrypted, using GSS API, and we'll speak about it in a moment. So maybe you should just check your environment, see, maybe you're blind to a lot of traffic you have in your environment that you assume that is unencrypted, but it's actually encrypted. So I just gave you a couple of more options that you can play with the Ldap set option function that actually have a great effect on the traffic itself. So after we initialize the connection towards the domain controller, we need to create the Ldap connect function. Actually, if we don't use it, the Ldap bind function just do it for us. So the bind function is a very important function because it's responsible for the authentication. So there are 2 functions that we can use here as well. The first one is the Ldap simple bind S function. So this one just gets a username and a password and creates a clear text authentication. So you can actually make sure that you don't use this kind of authentication in your environment. So just check that the authentication type is not 0. Since if it is 0, you have clear text credentials in your traffic, which is probably not a good idea. And also, if we're already speaking about authentication in Ldap, so maybe we can ask, why do we need authentication in Ldap? So first of all, every domain user have read permissions on the Active Directory. So why is it important with which user you authenticated? So first of all, not all the attributes can be read by all the users. For example, I talked about the MSDS managed password attribute. So this one can only be read by members of the principals allowed to retrieve password attribute. So it's quite important which user you are. Also, you can modify attributes in Active Directory, not only query them. And for that, obviously, you need to have the right permissions. So it's quite important with which user you authenticated. But maybe we should say you can also authenticate as anti-authority anonymous user. So this actually allows you to authenticate anonymously. So the GUI, you can see, it's the Ldap exe tool. So this one is default on Windows, and it's quite easy to use. So you just provide an empty string for the user and the password. And as you can see, I'm authenticated using the Ldap simple bind S function as anonymous logon. But you can see when I actually try to perform Ldap search query, I get an error. But later we will see that we still can use anonymous logon user in order to brute force enumerate users in Active Directory environment, which is quite cool. So the most common authentication function is the Ldap bind s function. So using the method parameter, you control the authentication type, which is very important because the key to decrypt the GSS API encrypted traffic is located inside the authentication, inside the bind response, and we will see it in a minute. So it's quite important to understand what authentication method you used in order to decrypt the data itself. So now we'll speak about the Ldap filter. So I just thought to myself it would be easier if we just take an example. So I chose the delegation vulnerable accounts filter since it combines a different type of filters and it's quite interesting. So we have 3 types of delegation. This filter is extensively used in multiple attack tools and attack techniques, so it also can be used for detections. So the first type of delegation we have is the resource-based constraint delegation, and to detect this one, we just want to make sure the MSDS allowed to act on behalf of other identity attribute is not empty. So for that, we just use a wildcard to make sure there is some value in it. Then we have the constraint delegation filter. So here we have 2 options. The first one is the MSDS allowed to delegate to. So again, we just want to make sure this value is not empty, and we use a wildcard. But there is also another option, another settings, that located inside the user account control, the trusted to auth for delegation flag. So here we have a bit of different situation, because this is not an attribute. This is a flag located inside an attribute. So we actually need to perform some bit-end operation on the attribute in order to understand if the flag exists inside this attribute. And for unconstrained delegation, again, we have the same case, the trusted for delegation flag, which located inside the user account control. So we need to understand how we can find it. So for that, we use something called Ldap matching rules. So this actually allows us to perform operations on Ldap attributes. So in this case, we will just use the following syntax. So we have the user account control attribute, and then we apply the Ldap matching rule. In our case, it's the bit-end rule, and you can see the OID that represents it. And then we supply the flag we want to search inside the user account control. So this is how we can check if the user account control has these flags. And to create the full filter, we just want to give an OR statement between either of these conditions. So we combine them all together using the OR statement, and this makes our complete Ldap filter. And the last thing we will talk about is the Ldap controls. So this is actually kind of a set of functions or options you can apply on your search request that has a great effect on the response. So I think best way to understand it is by an example. So for example, we see the Ldap server show deleted OID. So this one actually asked our Ldap server to retrieve also deleted object that fits the filter. There is also another option, the dir sync. So this one actually retrieve object that changes from the previous dir sync search. So this can be actually quite comfortable, maybe even for just use Ldap as a defender to make sure, see what changed and stuff like that. Now we'll talk about encrypted Ldap sessions. So I'm not going to speak about Ldap S in this talk, since it's well documented and I think we're all quite familiar with it, and there is also a lot of tools that support decrypting Ldap S traffic. So I'm going to speak about GSS API encrypted sessions. So we have 2 cases. We have Kerberos and ntlm, and we're going to decrypt each of them and understand the decryption flow. So we'll start with decrypting Ldap that encrypted with kerberos. So first of all, you can see in the upper left picture, you can see we have some Ldap bind response, and inside of it, you can see the kerberos blob. So this blob is actually the AP response, and we are going to extract the key from there. We'll see it in a minute. And in the bottom right picture, you can see the actual encrypted data. So this is Ldap search request, but it's encrypted using GSS API. And we can actually see this GSS API used Kerberos, since we have the kerb5 token ID, which is 0405, or in little Indian. So when you're actually looking at the code, it looks like 0504. But this is a good way to know that we are looking at Kerberos encrypted Ldap traffic. So let's decrypt our data. This is the encrypted payload, and we want to decrypt it and see the actual Ldap message. By the way, this is port 389, as you can see. So again, I'm just reminding you, if you think port 389 means unencrypted traffic, you should make sure you know what you're blind for in your environment. So first, we have one prerequisite, and that's a hash. So obviously, to decrypt information, we need hash. So we can use the kerb_tgt hash, the service hash, which is the domain controller hash, or the user hash. So I suggest using the kerb_tgt hash, since using it, you can decrypt all the Ldap traffic in your environment and not just a specific session. So the flow that I'm going to present here is used with the kerb_tgt hash. So first of all, we have the AS response packet, and inside of it, we have the encrypted ticket part. So we use the kerb_tgt hash to decrypt this part and extract a key from there. Then we have the TGS response packet. Inside of it, we have the encrypted TGS response part. So we use the key we extracted in the previous from the encrypted ticket part and decrypt this packet. And again, we use that key to decrypt the encrypted AP response part, which is located inside the bind response itself. We extract the key from there, and using that key, we decrypt our actual Ldap message. So actually, Wireshark has been very kind, and they just visualize us this whole process. So let's use Wireshark to see it, and it will be much clearer. So we can see the AS response packet here. You can see the encrypted ticket part, and you can see it's already decrypted, and there is a key inside. And if you look at the blue line on the bottom, it actually tells us it used the kerb_tgt hash to decrypt this information. So I provided the kerb_tgt hash, and Wireshark uses to extract that key. Now we are looking at the TGS response packet, and again we can see the encrypted TGS response part. It already decrypted, and it got us another key. And again, the blue line on the bottom tells us it used the learned encrypted ticket part key from the previous frame. Now for the bind response, so again, we can see we have encrypted AP response inside of it and a decrypted key inside of it, and again, it used the learned encrypted TGS response part key from the previous frame. And finally, we have the actual decrypted Ldap message. So you can see actually Wireshark knows this is Ldap, and it actually parses it as an Ldap message. So it's not, you will see later in ntlm decryption that it's not always the case. And you can see the blue line I highlighted this time, it decrypted it using the learn encrypted AP response part subkey from the previous frame. So this was a kerberos decryption flow, which is quite easy to understand. Unfortunately, that wasn't the case on ntlm. So Ldap encrypted with ntlm. First of all, you can see the JSS encrypted payload here. We can see now it's not kerberos, we have the ntlm SSP verifier. And in that picture, you can see the decrypted data tab. So as opposed to kerberos, when Wireshark decrypts ntlm information, it doesn't actually understand this is an Ldap message, and it doesn't parse it. So when you use Wireshark to decrypt Ldap, you will see actually the encrypted payload blob, and the data will hide in a different tab. So this leads me to a story time. So last year, I tried to decrypt Ldap traffic using kerberos and then using ntlm, and I found a really good article explains how to do it using Wireshark, so I did it. And for 3 days, I stared at the Wireshark screen, couldn't understand what I'm doing wrong, since all you need to decrypt Ldap that encrypted using ntlm is just provide a clear text password. So I changed the password and tried again, and changed the password and tried again, and nothing I did help. I couldn't decrypt the data. So I was pretty frustrated, and I sent a message to the author of this article, which is this guy, which is, by the way, amazing and helped me a lot. And like 10 minutes later, he replied saying that this is working, and I just looked at the wrong tab for 3 days. So I was quite sad, and he actually thought to himself, okay, if it happens to her, maybe it will happen to another people. So he had added an arrow to the article. This is a screenshot from the article, so it won't happen to you as well. The decrypted data is in this tab. So this arrow is actually my greatest contribution to the security community until this day, and I'm very proud of it. And At the same time, I also spoke with Dirk Jan about it. So we talked about the fact that you can see the data in a comfortably way. And I said, yeah, maybe I'll write something that shows it more comfortably. So actually, I did. So I developed a tool that implements the decryption process of Kerberos and ntlm encrypted traffic, and also parses the actual Ldap message and search for specific attack tools patterns. So I will demo a POC of this tool at the end of the talk, and it will also be uploaded to a GitHub repository. And there is also another surprise you will see in the end. Okay. So let's speak about the actual decryption flow of ntlm. So first, again, we have a prerequisite. This time, obviously, we don't have the kerb.tgt hash. So we need the service NT-hash, which is the domain controller hash. So just want to say the flow here is very random. I have no idea who created it. So I don't know, it's not me. So first we take the username and the domain name, we concatenate those and we uppercase them. This all located inside the ntlm SSP, which located inside the bind request. And then we use the service NT-hash as a key, and we create something that's called ntwf. So this is like a parameter from Microsoft documentation. Then we use this one as a key. And we take the NT-proof, which is the 15 first bytes of the ntlm v2 response, and we create something called base session key. Then we use the base session key as a key, and we take the session key, which is not the same, from the ntlm SSP part, again inside the bind request, and we create a decryption key. Then using two hard-coded strings, one is the server seal text and the other is the client seal text, we create two decryption keys, so a server decryption key and a client decryption key, and we use these to decrypt the actual GSS encrypted payload, which retrieves us the actual Ldap information. So it's quite important to say, since this is RC4 and we need to keep the context, so it's very important that you decrypt it in this exactly same order that the message appears, since otherwise it won't work. So I said I won't speak about LDAP-S, and I'm not going to. I just wanted to say that it's very well documented. All you need is a keylog file. You have multiple ways to extract a keylog file. I here put Frida and SSL keylog, but there's many options. This is how the encrypted data looks like, and as you see, like Kerberos and not like ntlm, after it decrypts the data, it actually parses the Ldap message, so you can actually walk through the pickup, the decrypted pickup, and understand what's going on there. And I just want to say there is the article I talked about with the arrow. So I put a link to it here. It explains all the process to decrypt ntlm and Kerberos information using Wireshark. So for Kerberos, you need a GitHub file. Dirk Jan created a tool that generates a GitHub file for you. It's quite easy to use. So GitHub file is just a file that maps user and its hashed password. For ntlm, you need one option is a GitHub file with RC4 passwords or just the clear text password. And for SSL, you need the SSL keys. So you can see this picture is the kerb5 preferences. So I just supplied the GitHub file for it, and it decrypts the data for me. And here you can see the SSL, the Ldap-S decryption. So I just provide the key file and the key file password, and it decrypts the data for me. And for the ntlm, I provide the clear text password, and we can see the decrypted data tab. So this is if you want to use Wireshark. Now for my favorite topic of this talk, which is Active Directory Web Services. So maybe you think this is a talk about Ldap. Active Directory Web Services is a different protocol. So what am I doing? So this was actually quite amazing. So what ADWS is doing is that it actually creates a SOAP XML message. This is its structure. And you can see this is actually have all the Ldap different parameters. We can see the filter, base object, scope, attributes. It also have controls. So this is actually pure Ldap, but in a different form, a different syntax, and a different port. So if you monitor Ldap traffic, you're not monitoring ADWS, but it's the same thing. So a couple of more things about it. It's actually much faster than Ldap, which is quite an advantage when you try to enumerate a whole domain. It cannot be seen with Ldap ETW client provider, and we will see it a bit later, and we will see how you can use ETW to see ADWS traffic. It's not supported by Wireshark, so we will see it in a minute as well. But the thing is that when it gets to the domain controller, it actually unwraps the SOAP message and runs Ldap locally on itself. So behind the scenes, it's still Ldap, you just don't see it in your traffic. And it's relatively unknown. So I'm not sure if it's unknown because as a defenders, we're not aware of it and attackers use it all the time, or that attackers doesn't aware of it either and now they're going to start using it. But it's so useful and I think we should all be aware of that. So before I move to the next slide, I just want to say thanks to Falcon Force and MDSEC, which were the only information sources I found that really helped me to understand the ADWS concept. So I put links to the 2 articles I used, and they're really explaining this stuff really good. So who uses ADWS? First of all, I was really surprised to hear that the Active Directory PowerShell module uses ADWS by default. So every time you perform the getAD user command, for example, you are not creating Ldap traffic, you're creating ADWS. And there are actually 2 tools that got released. One of them released just a few months ago, the Sharp ADWS, that actually took all the known Ldap enumeration techniques and just implemented them in ADWS. So if you're an attacker that want to hide from all the Ldap detections, you can just use these tools and you're finished. So this is a screenshot from Wireshark when you try to understand ADWS. So you can see it looks kind of different. The port is different, as we already said. So we have the ncheck done. And when you actually check it out, you can see this is GSS API. So actually, we can decrypt it, since we already implemented the unwrap function for GSS API. So maybe we need to parse it a bit different, since this is not a bind response information, but it's still GSS API. So the data itself, even though Wireshark knows how to decrypt it, you can see this is decrypted. Wireshark actually doesn't decrypt the data itself. I don't know why, probably just not implemented, but we can implement it, so I did it. So this is a screenshot from the data, so you can see it starts with 0504. So if you listened, you know this is kerberos encrypted GSS API. So Wireshark, for some reason, doesn't understand it, but it doesn't mean we can't. So I'm not going to speak about the decryption process, since it's quite similar to the other GSS API decryption process. It just required a different parsing. But actually, after we decrypt the information, we can see this pure Ldap, OK, a bit different looking, but this is an Ldap query. And it has a different structure, but it's still Ldap, and the response will be exactly the same as performing this Ldap query. So this is quite interesting. Remember it for later. So let's talk about defense. So we have a lot of attack tools and enumeration techniques we can talk about, and also these are they're well documented. A lot of people spoke about Bloodhound and AD Explorer before, so I only tried to bring something new regarding each and every one of them, since the known queries and stuff like that are already well documented on the internet. So we're actually going to start with Ldap nom. So I think Ldap nom is an amazing name for a tool. And this is also a really cool tool. So how you can create this amazing tool and not create a logo for it? You can't. So I decided to take this task on me, and I asked Dali to create a logo for this tool. So these are Dali's suggestions. As you can see, each logo incorporates elements of directory service with a playful touch, suitable for a tech project. I actually like the left one. I here approach to the author of this tool. You're more than welcome to use this as logo for your tool. So what Ldap nom actually does. So actually, it's really cool. It uses something called Ldap ping or cldap, which is generally used to verify the liveness of domain controller, but it uses it to brute force enumerate users. So this tool is actually using the anonymous logon user. You don't need to be authenticated as a domain user in order to use this tool. So what it does, it actually have a really static syntax, which is quite useful when you try to detect it. So you can see in the example, but it's actually the same every time. You have the NT version. This is static. Then you have the AAC. So this one represents the user account control attribute. So 10 represent normal account, but actually you can implement it by yourself and maybe search for different user account control values, maybe for, I don't know, different types of account. And then you just apply the user, and if the response starts with 17, it means the user exists. If it starts with 19, it means it doesn't exist. So this is actually quite cool. And quite easy to detect. Although, as I think I saw in the GitHub repository, that you can actually use it with Ldap as well, and then it's encrypted, so it's a bit more harder to detect. Now for AD Explorer, so we mainly use it for the snapshot utility, so you can use it to take a complete snapshot of your AD environment. It automatically encrypts its Ldap traffic using ntlm, and it was actually really hard to make it encrypt its traffic using kerberos. You actually can't make it encrypt its traffic using kerberos with the GUI. You have to use the CLI. In my detection process, I actually checked the ntlm case, and I noticed something quite interesting. The domain name in the bind process is always null. So in order to make sure, I used IDA, and as you can see, there is only one call to the Ldap bind as function, and just before it calls the function, it stores the EDX register, which used to symbolize the domain name attribute. So actually, it will always be null. And just to make sure of it, I downloaded a couple of random pickups I saw online for people that used ID Explorer, and it was null as them as well. So I'm like 99% comfortable that the domain name will always be null when you use ID Explorer. So this might be a fun way to sign the specific tool. So if you're suspecting someone use it, maybe you can use it to make sure. Since if you're monitoring Ldap volume traffic, you probably will notice someone is reading your all Active Directory data. So now for Bloodhound, which is an amazing tool. So this one is well documented, and we all know if we search online, we can see a lot of documentation about different Bloodhound queries. Since this one actually enumerates your environment, so you can probably see it. It actually has some Kerberos encrypted traffic, but not all of its traffic is encrypted. So I just added two things here. The first one is the fact that I noticed it uses the Ldap server show deleted OID control. I'm not sure. I tried to search in the code if it actually purposely used it, and I couldn't find it, but it requires a bit more research since I didn't finish the searching. So I'm not sure, but we can use it, again, just to sign the specific tool, since I noticed that other tools doesn't use this control. And I actually added here something that you can maybe use as a cheat sheet when you're trying to understand Ldap filters. So this one is quite known filter when it comes to Bloodhound. We can see it a lot. So I actually translated to plain English, so it can be quite useful because this one is pretty complex. So you can actually use it if you try to understand better the Ldap filter structure. Now for some random enumeration techniques. They are widely used in different attack tools. So there is a lot of buzz around certificate template in the couple of more last years after the Certified Pre-Owned article was released. So we can see a lot of queries that kind of look similar to that for the PKI certificate template. But actually, this screenshot is from CertiPy code. And it's quite interesting since each attack tool asks for a bit of different set of attributes. There are non-attack tools that look exactly the same set. So you can actually use the set of attributes to differentiate between the different attack tools, which is quite nice because, yes, you can know someone's tried to enumerate your certificate template, but it can actually be quite nice to know with which tool I tried to do it. Also, I added one Metasploit filter that looks for security groups. I like this filter, I don't know why. And also the DS internals, MSDS key credential link. So this one, firstly I saw it in DS internals, but later I realized a lot of other attack tools use it as well. And there is actually a really good Black Hat talk by Michael that I recommend you to watch that explains all the behind the scenes of why this filter is interesting. So it's really good talk. Now for Sharp ADWS, so this is Active Directory Web Services attack tool. I really liked it. So you can see here, for example, I use the kerberos command. So all this command does is actually take the known kerberos filters, so it's users with SPNs, and just implemented it in AWS. So you can see in the decrypted data, we are looking for user that has wildcard in the service principal name, so quite easy to detect. And also something interesting I noticed, every time AWS performs a query, it also performs this query, which kind of makes it obvious that this is Sharp AWS. I don't know why it does it, but it does. So it can be quite easy to detect after you decrypt the data. This one actually encrypts its data using ntlm, and Active Directory PowerShell module encrypts its data using kerberos. So now for the demo of the POC. So once I release it, obviously it won't be a video of my sad Python screen, and also hopefully CrowdStrike will help with my horrible UI skills. But this is what we have for now. So basically the tool receives some pickup. It can be encrypted with ntlm or kerberos. So in this example, you will see that this pickup is a pickup for AD Explorer traffic. So we can see the bind request. We can see that inside of it we have ntlm authentication. Also, we will be able to see that the domain is null since it's AD Explorer. And then we can see the data. So it's encrypted. You can see the decrypted data tab, which we can obviously not work with this thing. So I actually provide this pickup for my tool. I also gave it other pickups that describe different attack tools, the nom, the sharpound command, some delegation filters and stuff like that. So I give everything to the tool. It decrypts everything, and also the undecrypted Ldap data, it also documented it, and it creates a log for you. The log will contain all the decrypted Ldap filters. So this is first thing, if you want to just walk through the decrypted pickup and see what's going on there. And the second thing that the tool will do is to actually search for known attack tools signatures and create another table for you, only with the signatures it detected. So for each signature, you will see the tool and the technique, and we'll see it in a minute. So this is just the plain decrypted data. So you can see it quite easy to use. Also, I provided, we'll see it in a minute, but I also gave AWS encrypted traffic for that, so we'll see it in a minute. So this is the table that shows you, for example, for nom, it shows you on which user it tried to enumerate. For bloodhound, so you can see some filters, some certificate enumerations. You can see some delegation filters, so for RBCD. And some more enumeration techniques, and also for Active Directory web services. So again, I provided a pickup for it, which is encrypted. This is the Sharp AWS pickup. So it, again, decrypts everything, put it in a nice way inside the log file, and also shows you the table with the signatures. So we'll see it in a minute. Okay. Again, horrible UI skills, but you can see Sharp AWS, you can see the delegation filter, you can also see the attributes in this case. So this is quite nice. That's it for that. Okay. Now we speak about what we can do with Ldap for defense. So actually, the purpose of this slide is not to provide you all the possible queries you can do with Ldap, but it's to show you that with just a couple of lines of PowerShell, you create a pretty good defensive tool, which obviously won't cover all the requirements for defending your environment, but there is nothing to lose by doing that. It's free, it's default in Windows, so this is actually a really good thing to do. So I just provided examples here from some interesting Ldap filters you can do as a defender. So there are multiple advantages to do this. First of all, attacker will probably run the same Ldap queries. So you can see what the attacker will see when it will enumerate your environment. So this can be useful so you know your weak spots, and also maybe you can create some honeypots for it. So it's quite nice. It doesn't require anything. So I provided the kerberos double account filter, so it's just users with a service principal name. The kerberos pre-authentication disabled. So if you have results for this one, you are in a big problem. You should disable it immediately. The members of groups through nesting is one of my favorites, since it actually shows you all the members of, for example, here the administrators group, even if there are members of a group that inside the administrator group. So if you perform the net command, for example, you won't be able to see the nested group memberships. And the last one are two different filter queries for GPO. So you can't actually read the content of your GPO using Ldap, since it's not located inside the NTDS-DIT. But this is a quite nice way to just enumerate the passes of your GPO and the names and the priority and a bit more information about them. So it's quite a good start to make an automation that walks through your whole policies and then maybe go to the file itself and query it. And our last topic is ETW. So what we can do with ETW, we have two options. The first one is on client. So we have the Microsoft Windows Ldap client ETW provider. So to understand this one, I use ETW Inspector, which is a really nice new tool, and also Microsoft Message Analyzer. So there is a problem with this provider, since in the documentation, it tells you it actually documents multiple Ldap events, for example, the bind event. But when you actually use it, you see, for some reason, or maybe in my environment, it only documented event ID number 30, which is the most important event, so at least that. This is the search event. So you can see the search filter here, and the attributes. So there is quite a big advantage using this. You need to enable it, and this is on the clients. So you have one disadvantage, which we spoke about it before. You can't see ADWS traffic or filters using this one, since it's not Ldap. But for that, we have another provider. So this one located on the domain controller, and this is the Microsoft Windows Active Directory Domain Service ETW provider. So to enable this one, or to make sure this one documents all the Ldap filters, you need to mess with the registry a bit. So I put all the things you need to change on the registry in order to enable this. And this is actually very, very useful. Since it's on the DC, we can also document the ADWS events. So it's quite cool. For example, this screenshot, it's from the getAD user command. So this is Active Directory Web Services. And you can see the IPv6 for local IP, because Active Directory Web Services runs locally Ldap queries on the domain controller. So you can see the filter and the attributes, and you can also see the user, which is very cool. So this is, I think, the best way to do it, but obviously it's a bit problematic since it creates tons of events on your domain controller. So if you have a problem with storing these events, it's not that easy anymore. So that's just to conclude everything we talked about. So Ldap is very much alive. It's widely used. If Active Directory is still relevant, then Ldap is definitely still relevant. Decrypting Ldap traffic is very important, because otherwise you're probably blind for most of the attack tools and most of the Ldap traffic in your environment. Also, monitoring Active Directory Web Services traffic is important. I don't know why or if attackers use it or not, but you can actually avoid every big company security product detection if you just use Active Directory Web Services. And you can easily discover misconfiguration in your domain using Ldap for free. It's default. I really don't see any reason not to do it. And you can, and I think the word easily here, it's maybe not very correct, since it's quite heavy, because it creates a lot of logs. But it's easily from the fact that you only need to enable a couple registry values to monitor Ldap and Active Directory Web Services traffic using ETW. So that was it. Thank you.
Thank you very much for your great talk.
Thank you.
Hi, thanks. First of all, I didn't think I could learn anything new and interesting about Ldap, and I was very wrong. So thank you
Wow, when it comes from you.
thank you for the talk. On one of the slides, you mentioned that Active Directory web services had much better performance than Ldap, and I also read that in documentation for Pincastle, where you have an option to either do the queries through ADWS or through Ldap. But I never understood why. Maybe do you understand why it adds performance? Because I would expect decreased performance because of the proxying through web services.
Yeah, I actually expected that as well. To be honest, this time, and maybe I was wrong, I just believe Microsoft documentation that says this is a much faster option. But now that you ask it, maybe I shouldn't believe it that naive. So that's a great question. To be honest, I also expected it would be harder to do it since you need to unwrap and run it. So I don't know. It's actually a really good question. Yeah. Thank you.
Yeah, thanks for this very interesting talk. You said that ADWS proxies the queries to the actual Ldap service on the domain controller. I expect the kerberos GSS encryption to be terminated at ADWS. So how does authentication from ADWS to the backend service work? Have you looked at this? Can you say something about it?
So I'm not sure I understood the question. It's not proxying the traffic. It's just the traffic from the endpoint to the domain controller, but it's not Ldap. But when it gets to the domain controller actually knows how to unwrap the SOAP message and runs the Ldap on itself. But it's not. There isn't something like in between them that proxies this traffic. This is one.
The Ldap service on the domain controller. He needs to authenticate the user who's querying. And I expect this to be done with the user that authenticated to ADWS. So
I actually have no idea.
Okay.
Active Directory domain controller in delegation. So I would expect ADWS to do unconstrained delegation for the user and to delegate them to Ldap. I'm not 100% sure. Need to check that, but I would definitely expect delegation.
No, it makes sense. It's enabled by default on the domain controller. So yeah, makes sense. No, Andrea.
First of all, great talk.
Thanks.
I have a very, very easy question, so don't worry. Now, about ADWS, at the end, you told us that it's a simple Ldap query performed locally on the domain controller. So my question is there any chance, apart ADWS, to intercept huge and a large amount of queries by simply logging the Ldap queries on the domain controllers? Like, because normally you intercept Sharpadws or whatever tool for gathering information because you have normally a lot of queries provided which comes from the same workstation and so on, so you can trigger some filters. So the question is this possible to translate it directly on the domain controller if the source is ADWS or something like that?
I believe so. I mean, makes sense. I think so, yeah. And also might be interesting to do. Yeah. Also, something I forgot to mention. So you can also have Ldap encrypted using RC4 kerberos. So I don't support this yet, but I'm planning to. So this is quite important side note. So, yeah.
So I have a question too. If you want to decrypt the encrypted traffic, you need the kerberos.
Or the DC hashed password or the user hash password.
Yes.
Yeah.
Of course, how would you recommend to perform this in an organization? Because as you know, if you have the kerberos key, you are able to create golden tickets. You have the full power. So this means that that such devices needs very special treatment.
Yep, definitely. So maybe it's easy to say when coming from organizations such as CrowdStrike, but yes, obviously you need to retrieve the hashed password and you need to store it somewhere in a very safe way. But I think all of the defense tools these days have very strong permissions. Most of them also uses the kerb-TGT hash for other stuff.
Right.
So yeah, you need to store it in a safe way. But you also remind me another thing I wanted to say. So the GSS API encrypted traffic, it's not only for Ldap. For example, RPC can be encrypted using GSS API as well. So the code for doing this it's actually the same code, except retrieving the key is a bit different, since in RPC, for example, we don't have bind response. But you can actually use GSS API decryption process for other protocols as well. So it's quite important. So yeah, just reminded.
In addition to what Friedwart asked, if you retrieve the kerb-TGT hash, would you recommend, as soon as you have done that and you've done your exercise, to then reset that password? Once, obviously, or twice within a specific time frame?
So it depends. If you want to continuously decrypt Ldap traffic in your environment, you can do it, because then it will keep changing. But if it's for like a specific thing, I actually don't know, because I don't have a lot of experience with real-world environments. I think in large environments, changing the kerb-TGT password can cause, you may probably say more than I do, a lot of issues. So I think it might be a problem, because things will stop work. But obviously, there is a risk with retrieving the hash of the kerb-TGT account, and obviously you need to either store it or change it. Depends on what you're trying to do with the hash password. If you want to continuously decrypt the data, you can't change the password. Yeah.
Any more questions? No? So,
Thank you.
Talk.